Hello guys, in today's lesson we're going to have a general review of trigonometric functions. And let's just start by measure of angles. So there are two ways to measure an angle, radians and degrees. So what are these two? Degree is a measure of geometric angles and radians is the measure of arc lengths. So what is an arc length? Let me show it to you in the circle here. And we call the center of the circle O, here like A, and this one P. Let's put a theta here, and this one is a degree of that arc length of that arrow. That arrow have with positive x-axis, and the radian would be a measure of rotation that carries OA to OP. So we call it, for example, x. So x here is the radian of that circle. What else? Okay, let's not confuse both radian and radius together. So radius is here, like the distance from the center of the circle to the surface of it. So we call this radius. And as I said before, the measure of rotation that carries away to OP would be the radian of the circle, of that angle. Okay, so now let's draw another circle, and I want to show you guys how do we show it. So in a circle, so we call this point 0. This one is pi over 2. This one is pi. And this one is 3 pi over 2. This one is 2 pi. And we get like we have more explanation of these when we get into the sine and cosine, because that's the purpose of it, and we can get a better understanding of the circle. For example, here cosine is 1 at point 0 and sine is 0. So basically, if I want to give you a general explanation of what is sine and cosine is, so sine would be the y-axis and the cosine would be x-axis. So here, if you consider this one point positive 1 and here point negative 1, at point 0 the cosine is positive 1 and sine would be 0, because in the x-axis y is 0. And if we consider here positive 1 and here negative 1, at point 0, which is here, or pi 2, at point pi 2 we have a cosine of 0, because here would be basically 0, and we have a sine of positive 1, which we get over it like in a second, in a minute. And as I said before, for example, let's say we show x is an angle and we show y as a degree. So now, we show it as radians, right? So how do we convert angle and radians to each other? So let's say, if we say the angle over 180 is equal to y over pi. And if you think about it, it makes sense, because when the circle, for example, this point rotates to here, it rotates almost 180 degrees, not almost, exactly 180 degrees, which is equal to 1 pi. And here, when we try to convert this, we can see it exactly that we equal the 180 to pi. And that's how we do convert these together. For example, if we say, if we consider x as a 60 degree, so what's the radians of 60 degree? We put it on the equation, which will be like 60 over 180 is equal to y over pi. And if we calculate this one would basically be pi over 3. And I can show you the calculation, which will be like this. This one is 1 over 3. And yep, basically that's it, because this one goes that way and this one goes that way, so this one would be pi over 3. is equal to the radians is equal to the y. And this is how we do it. And okay, there are some general common angles expressed in degrees and radians, which I want to show to you, guys. So for radians and degrees, okay, 0 radian would be 0. Pi over 6 would be 13. So what is pi equal to? So as I show you guys here, when we go from this point to this point, we travel 180 degrees. So the pi is equal to 180 degrees. So we put 180 over 6 is equal to 30. So this is why I chose to write 30 here. Now again, pi over 4. Let's show it to you here. 180 over 4 would be what? 45. So we'll write 45 degree here. Let's not forget about the circle. And what about pi over 3? Again, 180 over 3 would be 60. And we write 60 down there. What about pi over 2? Again, 180 over 2 would be 90 degree. And we do this again until like we get to the point, we get to the some point. And we can do it like, for example, 3 pi over 4. Let's write it down here. 3 pi over 4. This one, if we say 180 times 3 over 4, what is it equal to? It's equal to 135 degree. And yes, that's basically how do we convert these together. So now let's go over the trigonometric functions. So as I said before, in a circle, let's draw a circle again, and redraw it. Okay, the x-axis would be cosine. Let's write here. So the cosine of is equal to x-axis, and let's call here y. The sine is equal to y, and basically that's it. So the domain of sine and cosine, because the domain of them are infinite, the negative and positive infinity. So let's write it. D of, let me write it down. Domain of sine and cosine are negative infinity and positive infinity. And the range, as I said, is equal to from -1 to +1. Because we show you guys here that this one would be +1, +1, -1, and -1 here. Okay. So, and we basically have some trigonometrics, 6 basic trigonometrics functions. For example, one of them is sine, as we said, this one, the positive and negative y axis would be sine. Let's say sine of t is equal to y. Let's say the cosine of t, as I said, the x-axis would be cosine. It's equal to x. What about the cosecant? Cosecant is the inverse of sine, 1 over sine, which will be equal to 1 over y. What about the secant? Secant is the inverse of cosine, right? So this one will be 1 over x. What about tangent? Tangent is sine over cosine. So in this case, this one will be y over x. And what about cotangent? Cotangent is the cosine over sine, and in this case, this one will be x over y. And yep, basically that's. So now let's show the sine and cosine of notable angles. So let's just start by sine of theta, and okay, let me just write it down there. Sine of theta and cosine of theta. So now, what is the sine of 0? I showed you guys before, but let's draw another circle here. Okay. So we basically said that the sine is the y-axis and cosine is the x-axis. So here, this is our point 0. What is the sine here? We don't have any number at the y-axis, so sine is 0 at point 0. And what about cosine? We said the range of cosine and sine is positive and negative 1. Let me just draw them here. Okay, so at point 0, we have the cosine of 1 and sine of 0. What about pi over 6? If we draw like pi over 6, it would be somewhere here. It's basically 30 degrees because let's calculate it. 180, which is equal to pi over 6. It'll be 30. And yeah, that's it. Now you guys can memorize this stuff, but they may give you this on an paper sheet, answer sheet. I mean, it's up to you guys. I would personally advise you to memorize them, which is what I do. So pi over 6 is equal to half for sine. Sine of pi over 6 is equal to 1/2. And cosine of pi over 6 would be the square root of 3 over 2. And pi over 4, these are the most notable and common angles, so I suggest you guys to memorize them. We have these 4, and okay. This one would be square root of 2 over 2, and pi over 3, sine of pi over 3 would be a square root of 3 over 2. And now I want you guys to notice something here, and I hope you guys have noticed it, but I would say that when I write it down, the cosine of pi over 3. The cosine of pi over 4 is equal to square root of 2 over 2, and the cosine of pi over 3 is equal to 1 over 2. So, did you guys notice it or not? What I meant was, if you look at it here, it's just basically, we said 1 over 2 is square root of 2 over 2 is square root of 3 over 2. And we exactly follow the same pattern, but in reverse, because we start off by square root of 3 over 2, square root of 2 over 2, and 1 over 2. So we basically just inverse the whole thing, and you guys can memorize one of them. Like, for example, you can memorize sine of pi over 6, and you say, okay, that's 1 over 2. Which one? This one is basically a square root of 1 over 2, but square root of 1 is 1, so you can just say 1 over 2. And it goes again, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. And then again, for cosine, you would say, oh, that's the inverse of the sine. So this one starts off by square root of 3 over 2, square root of 2 over 2, and the square root of 1 over 2. And you can make it easier by doing this. I mean, it's up to you. So another thing is the pi over 4, which is 180 over 4 would be 45 degree, have a same equal amount of sine and cosine. So the sine of pi over 4 is equal to cosine of pi over 4, which is equal to square root of 2 over 2. And we can basically use a triangle using this. For example, they saying, let's say, I'm trying to tell an example. Okay, let's imagine a triangle here. Okay, we call this part O, which is opposite, hypotenuse, and adjacent side, right? We put an angle T here. So what is sine? Sine of T, let me write it down like this, is the opposite side over the hypotenuse side, O over H. Cosine, and you can just imagine it like this. let's draw another circle here. Okay, sorry, this one is too bad. Okay, so if you have a triangle exactly like this, I mean, like this, right? Okay, this one is the x-axis, and this one is in y-axis. The y-axis is sine, and the x-axis is cosine. So this is what we're doing here. The opposite side over this hypotenuse side would be sine. And yep, you guys can use the circle here too. The cosine, so this opposite side over the hypotenuse side would be sine. The cosine would be the adjacent side over the hypotenuse side. This one is cosine. Adjacent over hypotenuse. What about tangent? Tangent, as I said, it's sine over cosine, which will be y-axis over x, which is opposite side over the adjacent side. O over A. What about the cosecant? Cosecant is the inverse of sine, which we should just inverse this one. So H over O. What about secant? Secant is the same as cosecant, which is, I mean, they're both inverse of the sine. Cosecant is the inverse of the sine, and secant is the inverse of the cosine. So secant will be H over A. And what about cotangent? Cotangent is the inverse of tangent, which is that instead of saying sine over cosine, it's cosine over sine, and in this case, A over O. And that's how we can show it on the triangle. For example, there is a question that's saying, let's say, find the cosine of x, tangent of x, if sine of x is equal to 3 over 5. I want you guys to think about it. Like, how should we approach this problem? First, we draw a triangle like this. What is sine? We said here, sine is the opposite side over the hypotenuse. So if we say the sine of x is equal to 3 over 5, let's not forget about the angle here. This side is 3, and this one is 5. And how should we measure this one? Using the rule, I'm going to show you guys the rule. For example, A, B, C. A with the power of 2 plus B with the power of 2 and is equal to 3 with the power of 2. I'm sorry, guys. I forgot what it's called. But yeah, that's the rule here. Okay, and how can we show it? Okay, no, let me just copy it down here because I can give you the files. Let's move it up there. Where should I put it? Okay, I'll put it here. That's the rule for it. Okay, how should we calculate this? So it's basically there's an x with the power of 2 plus 3 with the power of 2 is equal to 5 with the power of oh my god, 5 with the power of 2. And if you put this one here, would be x with the power of 2 is equal to 5 with the power of 2 minus 3 with the power of 2, which is basically x with the power of 2 is equal to 25 minus 9 is equal to 16, and the square root of 16 is equal to 4. So that side is equal to 4. So it says, what is the cosine of x? We said the cosine of x is equal to adjacent over the hypotenuse. So this one will be 4 over 5. And what about the tangent of x? We said the tangent of x is equal to sine over cosine. And now we have two ways to write it down. The simplest one will be the opposite side over the adjacent side, which is 3 over 5. Or we can do it the hard way. We said the sine is equal to 3 over 5. and the cosine is equal to 4 over 5. So if we do it that way, it is 3 times 5 over 4 times 5. Now we can cancel these 5 together, and this one is 3 over 5. And that's how we find the cosine and everything using the one of the above. Like in this question, they gave us sine. And we can also find other stuff like cotangent, cosecant, secant. So what is secant? Secant is the inverse of cosine. So in this case, this one will be 5 over 4. What is cotangent? Cotangent is the cosine over sine. And in this case, we can say the adjacent side or the opposite side will be 4 over 3. And that's it. And this is how we calculate this. So now, there are some basic rules that you should know about. We call them trigonometric identities. One of them is sine of x with the power of 2 plus cosine with the power of 2 is equal to 1, which is simple. The cosine with the power of 2 plus sine with the power of 2 is equal to 1. Another one is 1 plus tangent with the power of 2 is equal to secant with the power of 2. Oh, let's not forget about the x. And again, 1 plus cotangent with the power of 2 is equal to cosecant with the power of 2. Okay, and there's an addition identities which can be useful, very useful. For example, sine of x plus y. Now here, for example, it says sine of 30 plus 45, for example. We can't just separate them. We have to calculate them this way. It says sine of x times cosine of x plus minus, okay, let's not forget about this one, plus minus cosine of x times, oh my god, I'm sorry. I forgot about this one. Sine of x times cosine of y is plus minus cosine of x times sine of y. And now I'll get an example of this one because I explained it bad. Okay, but the thing would be different for cosine. So in cosine, when you say x plus minus y, it would be cosine of x times cosine of y, and this one will be changed. It won't be plus or minus. This is going to be inverse of it. Minus or plus sine of x times sine of y. Now there are double angles formulas, and this one, for example, sine of 2x. So we can just say, okay, sine of 13, for example, is equal to 1 over 2. And now, since this is sine of 2x, we can say, okay, now it's 2 over 2, which is 1. No, we can't do it like this. We say the sine of 2x is equal to 2 sine x cos x. And the cosine of 2x would be cosine with the power of 2 minus sine with the power of 2. And yes, that's basically how we show it. So now let's do this. So now to give you guys an example, okay, let's say sine of pi over 3 minus pi over 4. So how should we approach this one? As we said before, we have to use the formulas because we can't just separate them. Like, we can't just say sine of pi over 3 minus sine of pi over 4. We have to use the formula to get the correct answer. So here, what we said was sine of pi over 3 times the cosine of pi over 4 minus cosine of pi over 3 times sine of pi over 4. So now we just have to calculate this one. What is the sine of pi over 3? It's basically square root of 3 over 2 times. What is the cosine of pi over 4? We said square root of 2 over 2 minus. What is the cosine of pi over 3? That's basically the opposite of this one. So we approach 1 over 2. If you guys remember what I said about this one, this is why I said the opposite of that one. Times, what is the sine of pi over 4? And as we said before, the sine of pi over 4 is equal to the cosine of pi over 4, which in this case would be square root of 2 over 2. And now, this one is square root of 6 over 4 minus square root of 2 over 4. And we can just show like, oh my god, what happened? Okay, and we can just show it like square root of 6 minus square root of 2 over 4, or we can factor out the square root of 2, and this one will be 2 times square root of 2, and square root of 3 minus 1. Both way of writing it would be correct. I mean, it depends on how you prefer it. Like some people don't write this one as square root of 2 over 2. They write it as 1 over square root of 2, and they're both are correct. Because if you multiply this one by square root of 2, because what is the square root of 2 over 2? It's 1. So we just basically multiplying this one by 1. So nothing would change. This one is equal to square root of 2 over 2. And as you can see, this one is equal to this one, and nothing changed. So now let's see what else. Okay, I guess that's it. That was a great lesson, guys.